So chapter 9, problem number 32 reads, what is the angular momentum about the axle of the 500-gram rotating bar in figure P9.32? I've redrawn the picture right here. It's just a rod with an axle in the middle that is spinning around at 120 revolutions per minute. So usually the first thing that we want to do to make our life a little easier is if we're given it in revolutions per minute, we want to convert that to radians per second. Because it just makes our life a little easier and it's the most basic unit we can use. So we start with 120 revolutions per minute. One revolution, one time around, is equal to 2 pi radians. Okay, and then we're going to convert those minutes. So 1 minute is 60 seconds. So when we do 120 times 2 pi, and then we divide it by 60, we come out that it is 12.6 radians per second. Okay. Now from there, we need to determine what is the angular momentum of this rod then. All right, so we go with our equation for angular momentum, which is L is equal to I times omega, and we plug in what we've got. This has a specific moment of inertia equation that we can look up on a chart. I gave you the paper, and we find that it is 1/12 mL squared, and then times omega. So it's 1/12 times the mass of the rod, which is 0.5 kilograms. Always change those grams to kilograms. L, the length of the rod, is 2, so we're going to square that. And then omega, which we found up here, is 12.6 radians per second. So that when we solve for the answer, we get all this out, we do the multiplication, we get that the angular momentum of this rod as it rotates around its axle in the middle like that is going to be 2.1 kilogram meters squared per second.